So we want to take a look at one last kind of logarithmic equation. And this is where the logarithm equals a number. Note that we can't do a common basis thing here because I have a log base 2 on the left and I don't have any logarithms on the right. So the instructions change just a little bit. We still want to condense the logarithm, and in this case, I don't have anything to condense it with. We also want to make sure that logarithm is isolated. In our case, it is. This is all one term. It's already isolated. However, we now can write an exponential form, and that's going to be what's new. So keep in mind, we wrote exponentials in logarithmic form before. This is just the inverse of that. So my base is 2, and I'm going to switch my left and my right. So that 6 becomes an exponent, and the x minus 4 goes on the right-hand side. Remember, with inverses, we switch the left and the right, and that's exactly what we did here. The input and the output switch. So note that x is not by itself yet. It's not too bad. We can add 4 to both sides, and that will get x by itself. So on the left, we have 2 to the 6th power plus 4. And on the right, we just have x. So if you're not comfortable with your powers of 2, your calculator can handle this. Your calculator can take that all as one step, 2 to the 6th power, and then again to that we are adding 4. We do get a nice number out of this because 2 to the 6th power is 64, but if you're not comfortable with those exponents, feel free to use your calculator. That is what it's here for. So we wind up with x being 68. Just like with the previous ones, it's worth our time to go back and check for extraneous solutions, because it's possible that that 68 actually breaks our logarithm. So going back to our original equation, remember alpha f2 brings up our log base menu, and we get log base 2, and then x minus 4, I'm claiming that x is 68. 68 minus 4. When I hit enter on the calculator, I had better get back the number 6, because that's what the equation says. Log base 2 of x minus 4 equals 6. Lo and behold, that's what I got. So this solution checks out, and life is good. Let's take a look at another one. We don't have to worry about any properties. There's no condensing to take care of here, but there is an isolation to deal with. This log is not by itself just yet. So in order to fix that, we're going to add 7 to both sides. Negative 3 plus 7 is going to be a 4. So now I have my log isolated. We're good to go ahead and do exponential form. So with exponential form, my base doesn't change. This is still base 3. But my inputs and outputs switch. So that 4 becomes an exponent, and the 4x plus 8 goes on the right-hand side. So this becomes a two-step equation. In order to get x by itself, I need to do 2 things. First, I need to subtract 8 from both sides. Go ahead and get some more room there. So first I need to subtract 8 from both sides. And then I need to divide by 4. So note that this whole expression can all go in your calculator at once. You are certainly welcome to do that by hand if you like, a step at a time. It wouldn't be too time-consuming, but I'm going to use the calculator to just show you how quickly the technology can handle those kinds of numbers. Alpha F1 brings up our fraction menu, The very first option is just your standard fraction. And then in the numerator, we had 3 to the 4th minus 8. And in the denominator, well, remember we divided by 4. Your calculator can not only handle this for you, but it gives it back to you in simplest form. So 73/4 is the answer for our value of x. Again, you could have done that by hand, but I just wanted to show you that the technology can handle it for you. The technology is also great at helping you check your work. So I'm making the claim that log base 3 of 4x plus 8, again, that x value, I can scroll up and grab it. Your calculator will put it right there where it belongs. So 4 times that value plus 8, that's all inside the logarithm. If I subtract 7 from that number, I had better get back -3. Uh-oh, syntax error. Let's see what I screwed up. It appears I have one too many parentheses. If you are having trouble diagnosing your own syntax errors, let me know. I'm happy to help you out. In my case, third time was the charm. So let me know if you're having similar calculator issues. I'll help you point out the parenthesis error or possibly the fraction weirdness. But again, your calculator can do this very quickly and a bit more accurately than most humans can do with pen and paper. So make sure you're checking your work. In this case, I did get back the -3 that I expect. So the solution checks out. Last but not least, let's take a look at one where we do need to condense. So note that I have an addition on the outside. That's going to become multiplication inside. So what I mean by that is that this logarithm, in this case it's a log base 10, is going to have a 2x times x minus 5 when I go to condense. So we do have to deal with a distributive property here. As a heads up on your practice, you might have to deal with a FOIL. Get ready for it. So inside of this logarithm, I have a 2x times x. Well, that's just 2x squared. And then I also have a 2x times -5, which is a -10x. All of that equals 2. So now my logarithm is condensed. It's also isolated, which is good news. So from here, we're good to go ahead and rewrite in exponential form. Now we need to be careful. This logarithm does have a base. There's nothing down here. So when nothing is there, the base is 10. So in other words, that 10 is the base of my exponential. The 2 comes over to the left. And that inside, the 2x squared minus 10x goes on the right. Again, that's just inputs and outputs switching sides, because exponentials and logarithms are inverses. So we can clean this up quite a bit. 10 squared is 100. And note, I have a quadratic here. So because of that distributive property up top, where I had to multiply the x by the 2x, that gave us a quadratic equation. So to solve a quadratic, I want to get all of my terms on the same side. Subtracting 100 from both sides will do it. And if you notice, this quadratic has all even terms. So I can make all of these coefficients a bit smaller by dividing both sides by 2. Note that if I divide 0 by 2, that's still just 0. On the right-hand side, though, every single one of those coefficients will get cut in half. So I'll have an x squared minus 5x minus 50. Quite nice. And now we get to bring back our favorite F word, factoring. I need two numbers that multiply to -50 and add to -5. So if you'd like, you can build the whole table. 1 and 50, 2 and 25, 5 and 10. There aren't too many to check. In order to make sure that we get a -5, my bigger number needs to be negative. So 1 plus a -50 is -49. That does not work. 2 plus a -25, that gets us a -23. That does not work. 5 plus a -10, that gets me a -5. Ding, ding, ding. That's the pair that I want. So my two factors are x minus 10 and x plus 5. So keep in mind when you find factors, the number inside of the factor, in this case a -10, its opposite is the possible 0. So if -10 is a factor, then 10 is a 0. If x plus 5 is a factor, then -5 is a 0. Now we just got two answers for this equation. That's a bit suspect. It's always important to go back and double check your work. Let's start with the 10. So we're making the claim that log base 10, remember your calculator is a special button for that, of 2 times 10, if I add to that log base 10 of 10 minus 5, this should give me back the whole number 2, because that's our original equation. And it does. So the 10 does work. That checks out. Let's check the -5. And I'm just going to go ahead and scroll back up and change that 10 to a -5. It's possible you already see what's about to happen. When I hit enter on my calculator, I get back error, non-real answer. If we go to the error, it'll actually show us the problem here. Guess it didn't quite. The problem is right here. -5 minus 5 is -10. We can't put a -10 . Apologies, I noticed after the fact when I typed that in, I actually lost the logarithm. So here we have it again, brand new. When I hit enter on my calculator, I get the same error, non-real answer. So when we go to, notice it's showing us that there is an issue here, and that's that -5 minus 5, which gives us a -10 inside the logarithm. So what that tells us is that -5 does not work. We only get one solution, and that solution is 10. So let me know if you have any questions on these. We've looked at a lot of equations in this section, some exponential, some log equals log, and now we have some log equals number. Go ahead and try out the practice, and just give me a holler when you find out that you need something. And if you're having issues with the calculator, hey, it happens to the best of us. Raise a hand, I'll help you find the error. I'll help you find those buttons. And keep in mind, if your log base is a different setting than mine, we can look through the catalog and find yours as well. Just let me know what you need, and I'll see you soon.